right, folks, so we're starting on page 5 in the practice set, and we are going to wait on 54 and 55 for right now. By the end of the day today, you should be able to do those two problems. But we are going to look at 56, 57, 58, and 59. Now, it says solve each equation. I want you to add by factoring. Homework packet, page 5. So solve each equation. We're going to solve by factoring. And we are going to check using our calculator graph, because that's going to tie us into what we will need to do when we aren't able to factor, when we get a prime expression. So folks, taking a look at 56, if I tell you to solve by factoring, what's the very first thing we check for? GCF, and we do not have one. So we've got a power of 4, which makes me think fake quadratic, but is there anything jumping out at you about 625? It's a big number, and if you're like, I wonder if it's a perfect square, how could we check? On your calculator, above the x squared, we got square root, so square root 625, and ta-da, we see that it is a perfect square. So I can factor this as the perfect square factors of m to the 4th, which would be m squared and m squared. Don't forget your equals 0. And the perfect square factors of 625, which would be 25 and 25. One gets a plus and one gets a minus. Can we factor that a little bit further? Yes. Which one or both? Just the minus one. So we've only got difference of squares. So this one I can factor again. So m squared plus 25, m plus 5, m minus 5 equals 0. Because there is no sum of squares. There's no way for me to get a product of 25 and a sum of 0. Because in order for our outside-inside products to cancel, one of them's got to be positive, one of them's got to be negative. And that would give you a negative 25, not positive 25. So, folks, from here, we have something times something times something equals 0. So what do we know about those somethings?
They're positive.
One of them's got to be 0. So m squared plus 25 could be equal to 0. M plus 5 could be equal to 0. M minus 5 could be equal to 0. And remember, this is the same way that we found roots way back in Unit 3. M equals negative 5 is a root. M plus 5 is a factor. M minus 5 is a factor. M equals 5 is a root. So from root to factor, your sign is different. Now, how am I going to solve this one? First, we want to isolate our m squared by subtracting 25. Then what? How do I turn m squared into m? Square root, square root. And when I square root, what must I include? Plus or minus. Woo!
Imaginary.
And we're going to have an imaginary time here. So what I? 5i. So square root of 25 is 5. Square root of a negative is I. So plus or minus 5i. All right, folks. So now the big kicker. How many total solutions did we find for this polynomial?
4.
Positive 5i is 1. Negative 5i is 2. Negative 5 is 3. Positive 5 is 4. So 4 total solutions. And what I want to point out to you is the degree of the polynomial is 4. And our degree will always tell us how many solutions we should have. So degree 4 means 4 roots, 4 solutions. And that's a good thing to check yourself as we start moving into the next section, is that our degree should always be equal to the total amount of solutions. So if I done goof and forget my plus or minus, I say, ooh, I only have 3 and I should have 4. This is a way that we can check ourselves. The other way that we are going to be checking / solving in the next section is using our calculator. Folks, go ahead and go to your y equals. clear out any junk that's in there. And we're going to type in this equation, and instead of variable m, we're just going to use variable x. So x, caret button 4, arrow over to escape the exponent, and then minus 625. When I graph this, what am I going to see?
-5 and a positive.
The -5 and +5. So I'm going to see these as x-intercepts. Pew, there's -5. Pew, there's +5. Am I supposed to be seeing those imaginary ones? No. Should I be seeing any additional x-intercepts? No. So if I was seeing extra ones, maybe this shouldn't have been an I, and maybe it should have been something else. So we can check ourselves visually on our graph and count over by tick marks, saying that's -1, -2, -3, -4, -5. We can also use our trace button. So go ahead and hit trace. And trace engages your x equals y equals. If I just type little -5 and press enter, it tells me the output of that value. And this is how we're going to test P over Q values. More on that later. So you can test +5, you can test -5, and that ensures that those really are roots or x-intercepts of our function. So now we're going to move into our next problem, number 57. What's the first thing we check for when we're factoring? Do we have one?
Yeah.
There's no number we can take out of both other than 1, but how about variable-wise? N squared, take it out. So n squared. And that leaves me with n squared minus 49 equals 0. Can I factor that a little bit further? Why? Difference of squares, a good one to have on your radar. So n squared, n plus 7, n minus 7. And before we go any further, our degree of this polynomial is 4. So how many roots should we have? 4. The degree is equal to the number of solutions we should have. Nope, degree is the highest power when it's in standard form. So that adding of powers, that's what we did when it was in factored form. So highest power in standard form, that is our degree. So folks, now we have something times another something times another something equals 0. So either this something is equal to 0, this something is equal to 0, or this something is equal to 0. Solving this one, n would be equal to 7. There's one root. Solving this one, n would be equal to -7. N squared, square root. And n equals plus or minus 0. Is positive 0 and negative 0, are those different? No, so we can actually just simplify this to be 0. But since we technically got 0 twice, or if we go back to n squared that has a multiplicity of 2, technically, we know that this is going to bounce at that root. So that goes back a little bit to Unit 3 as well. You can draw a cloud around that. That's not something you have to know. But that plus or minus 0 is technically 2, even though it's the same root twice. So technically we found 1, 2, positive 0 is 1, negative 0 is another, even though they equal the same thing. So our degree does match our number of roots. So let's go ahead and type this equation in using variable x here. So x to the 4th, arrow over to escape the exponent, minus 49x squared. And you always want to go back to the original equation and not the factored form, just in case you goof somewhere. And what do we see? There's our root at -7. There's our root bouncing at 0. And there's our other root at +7. And if I use the trace button, I can verify, all of those. And we see that we get y values of 0 for all of them. So this graph component is important for being able to check ourselves. So let's go ahead and, does anybody have any questions so far? Let's go down to 58. Now for 58, do we have a GCF? No. This one is a fake quadratic. And how do we factor those fake quadratics? We use the x method, similar to how we did regular quadratics that had an a value. So how can I get x to the fourth, x squared, and x squared? And it's always going to be x squared and x squared, not x to the first and x cubed. So x squared and x squared always. For 14 and 1 versus 7 and 2, let's do 7 and 2. Multiply on the x. X squared times 2 is 2x squared. X squared times 7 is 7x squared. Now, if I need my sum to be negative 5x squared, who needs to be negative? The 7. So that 2x squared minus 7x squared will give us a negative 5 for the sum. So that means that 7 needs to be negative. So going straight across our factors. And folks, I'm actually going to sidebar over here with my factors to make the most of this space. We'll have x squared minus 7 and x squared plus 2. Can I factor those any further? Neither. If it's two terms and there's no GCF and it's not difference of squares, that's it. Not factorable any further. So now we can use our zero product property. We have something times something equals 0. So we can set each of those equal to 0. X squared minus 7 equals 0. X squared plus 2 equals 0. So x squared equals 7. Now what? Square root. And x equals plus or minus. Can I simplify the square root of 7? No. So how many roots did I just find? We just found 2, and we should have 2 more. So our degree is 4, so there should be 4 roots. Square root of 7, is that a friendly number? Not at all. But using my calculator, I should still be able to check that on the graph. So let's go ahead and solve the other side. So x squared equals negative 2, square root, and x equals plus or minus, is it 2i or I rad 2? So the negative comes out as an I. Is 2 a perfect square? It's not. So that 2 is going to stay underneath the square root. So I 2. So how many solutions do we find total? We found 4. How many of these are we going to be able to see on our graph? Only those 2. So, folks, we're going to type this sucker in. And I want everyone to type this one in. Make sure the graph is all working good because you'll need it for the homework that we do today. So, everybody type this one in. Now, how many roots should we see? 2. Are they going to be on those tick marks? Nope, because square root of 7 and negative square root of 7 is gross. So you should see something like this. Is anybody's calculator graph doing anything weird? Or are you not seeing this? Is it zoomed funny? Anyone have any?
Yeah, mine doesn't look exactly like that. Wait.
You gotta graph this. The fake quadratic equation.
Hey, yo. What happened?
Zoom standard. Oh yeah, you got something. That's how much your thought is. There you go.
I'm right on the right side, but I'm wrong on the left side.
Oh, you need a square root.
I got that.
Oh my
Yeah,
god.
that's
I'm
probably
quitting that.
important.
Oops, and then what if I put
Oh,
Come on, grab it.
I know that. Andy, sorry.
Thank you.
I think I got
Anybody's
it.
calculator not showing
It's
there?
in between 2 and 3.
Hey, spoiler alert.
Shut up, Carson.
Wait, how do you?
I'm gonna take apart the root.
Ooh, so that one. Type in that one. I was like,
Okay.
it kind of looks
Yeah,
right.
you should take the stickers off.
You're mad? Oh, when you said.
Y equals,
I'm literally.
type it in.
Oh, wait.
How, yeah.
Mhm.
Hold up, how do you do this?
Okay, folks, so now
You don't want to.
we see that this x-intercept is between tick mark -2 and tick mark -3. I can check it exactly, eyeballs. Let me see your eyeballs.
Alright, my fingers are
By hitting trace and square root, so second x squared of 7. That nasty decimal does give me that exact root. I can check the negative version as well. Hit the trace button, hit second x squared, and type in, before the square root, type in the negative. So negative square root of 7. And that gives me the other one. So folks, this is really nice because these gross answers, as long as there's no I with it, we can check them exactly on our graph. What questions do you guys have so far? All right, super duper. So folks, I'm going to give you, well actually, let's just start with the calculator on this one. Let's just type this in and see what we can see. So first, our degree is 4. So how many solutions are we going to have? 4. So degree is 4 roots. We type in the equation to our y equals. Wow. How many x-intercepts do we see? 4. So this is kind of nice because it tells me that all 4 of them are going to be real. So that means I should be able to factor it, but none of the factors look like they're going to come out nicely. None of those x-intercepts look like they're exactly on the grid. So let's go ahead and try to factor this. I'm going to give you 2 minutes to get as far as you can with solving this problem. It is a fake quadratic. It goes 4, 2 constant for the power, so you will need to use the x method.
I just put it in.
Yeah.
Shut up. I took out a knife. I was getting dogged on there. It is. I'm really the best in the game. Lovely. The what? I don't know if the stuff is ice cream.
So 14x squared, 3x squared. If we need the sum to be negative 17x squared, we need both of those to be negative and both of those to be negative. And again, checking to make sure those give me a product of positive 21. So folks, I'm going to go ahead and write my factors over here. 2x squared with the negative 3. And then 1x squared, or just x squared, with the minus 7. So I have something times something equals 0. Can I factor either of those any further? It's not difference of squares. There's no GCF. Nope. We are good to go with just starting to solve. So let's set this one equal to 0. 2x squared minus 3 equals 0. This one equal to 0. So 2x squared equals 3. We have to divide by 2 before we square root. Square root, square root. And x equals plus or minus the square root of 3 halves. And make sure you show that entire fraction underneath the square root. There's 2 solutions. Solving the other side, we got x squared equals 7, square root, and x equals plus or minus. Can I simplify the square root of 7? Nope. How many total solutions did I find, folks? 4. We've got positive square root of 3 halves, negative square root of 3 halves, positive square root of 7, and negative square root of 7. And because those are all real, I can check all of those on my calculator. What button do we press? Trace. So trace square root of 3 halves. Boom, there's 1. Then negative square root of 3 halves. That's another. Then square root of 7. Then negative square root of 7. So we are able to check all of the real ones, as nasty as those decimals are.
Ladybug.
So when you trace, you just go straight to the number or square root, or you can.
So yeah, when I hit trace, let's zoom out here. So hit trace, and then I can type in second x squared. So you just start typing, and that immediately engages that x equals. All right, folks. So I think,
This carrot, come look at this.
is it a real ladybug or is it one of the orange ones?
No, look at it.
It's one.
Dude,
It's a
I
ladybug.
really hope it's fake.
Oh, aren't the orange ones like the ladybugs?
It's a ladybug.
Aren't they different?
No, that is red. He's just he has a tan. Oh my god, he's fast, bro.
Yeah, mine's in there.
Careful, I think they
No idea
bite.
what to do.
All right, folks, we're going to turn the page, and before,
I'm gonna let him outside. Is it too cold for him?
no,
Probably you can die.
we're going to turn to the next page. Oh my God.
Okay,
Yes.
It's definitely not a real ladybug.
His wings is willing.
A beetle.
Oh, your plot's on.
Trigger's the beetle expert.
Yeah, I am.
I forgot you guys were goddamn ladybug professor.
All right, folks, so here's what we are going to do. I want you to look at number 60. On the next page, we're still in the homework packet. Can we take out a GCF?
Yes.
Oh, this is the one where it's like weird plus minus thing. Or like, this is the one where you split it in half, right?
This is the one where you split it in half. So, folks, there is no GCF I can take out of everybody, but since there are 4 terms, this is grouping. So this has a degree of 3. So there will be 3 roots or 3 solutions. So split it in half. GCF from the first pair, x squared.
I can't get him out. He doesn't like my pencil. I'm not grabbing him.
What's my GCF from the next pair?
He's scared of my pencil. Just bro.
What?
I need help.
1 second.
He's stuck under here.
So folks, just let him climb out.
I'm trying to get him
Quit
out.
poking him.
Same.
They are not the same. Is there anything I can do to make them the same?
No.
That's a no. So we can't factor it. But does that mean there aren't solutions?
No.
No, because we know there should be 3. Let's see what this looks like on our calculator. Just type in that equation. So x cubed minus 5x squared plus 5x plus 3.
Oh.
Oh.
Got him. He's free.
So interesting. You may have expected that since we can't factor it, that maybe the solutions are imaginary. But this shows me that all three of them, 1, 2, 3, are actually real. So folks, we are kind of stuck here. They're probably going to be nasty decimals. So how are we going to find them? There is no polynomial formula like there is the quadratic formula. So that's going to lead us into what are called P over Q values, or using the structure of the equation to find potential rational roots. So that's what we're going to be heading into after our homework quiz today. This was kind of a nice little review of what factoring by grouping was. So we are now going to do the homework quiz over factoring.
Bro,